A new project has been launched to support innovative and cost-effective energy rehabilitation in public buildings. It's a project that's coordinated by the Foss Research Centre for Sustainable Energy at the University of Cyprus. And the project coordinator joins us now. He is Professor Yorgos Georgiou. Yorgos, tell us first of all about the whole idea behind this project, because you have, I think, partners in several other Mediterranean countries.
Yeah, so this is a project that is a collaboration between the University of Cyprus, the University of Cagliari in Italy, the University of Western Macedonia in Greece, and Ben Gurion University in Israel, and the municipalities of Eilot and Eilat. And this project is funded by the Mediterranean Programme, the ENI, which is a European initiative. And the whole idea behind what we have been trying to do is to try to develop and increase the penetration of photovoltaics by using battery storage, but at the same time rendering the whole building into a nanogrid system.
Now that's what I wanted to ask you about, because I read about these nanogrids and microgrids. For the uninitiated like me, what are we talking about here?
In the case of a nanogrid, we can be talking about a building that can have production, can have energy storage, so the production could be the photovoltaics, battery storage to store the energy, consumption, the building inhabitants, and at the same time you do an intelligent management of the load and the production, and you can also be disconnected from the grid if you wish so. If you go to a bigger scale, then you're talking about a microgrid. So in our case, we want to take the nanogrid, and we consider as our nanogrid one building. In the case of Israel, it's a school. In the case of Greece, it could be a building in the university campus. The same will happen here in Cyprus. And in this way, we can have a smart management of our loads, our production, the battery storage, so that we can enable further penetration of the technology.
Right, when we say a grid, again, I'm not familiar with the whole system, but when you talk about the electricity grid, for example, it's serving lots and lots of people. So could the grids in these houses, once they have been, or these buildings, once they've been rehabilitated, also serve surrounding buildings, if you see what I mean? Do you get then a cluster of like a mini power station?
Absolutely, that's the whole idea. We are moving towards microgrids, we are moving towards distributed generation. We have the main grid that can be used to provide us with electricity, but at the same time, right now, we are producing with photovoltaics, let's say, so we can become small nodes that can produce electricity.
Not just for your own use, but also for the surrounding buildings.
But to start with, yes, you can start by increasing your self-consumption, and then, of course, there will be flow of energy, if you wish so, to other surrounding buildings as well. But predominantly, you want to do it for your own needs.
Can this be rolled out for other applications? Once you've got the system in place, because this is a research project after all, you've got to see if it's going to work and how it works and whether or not even climatic conditions could make a difference to its efficiency, I imagine. So once you've got that information, could you roll it out, let's say, to every school in Cyprus?
Yeah, this is what the future, the way things will be operating in the future will be very different. Up to now, we know of a one-directional flow of energy from the power stations to the consumers.
Or hang on a second, or for the few people who did put photovoltaics on their homes, then they're pretty well self-sufficient, and I'm not sure what happened with selling some excess back to the electricity authority grid. I don't know if that's still happening or not. But if you had that in whole neighbourhoods, you wouldn't actually need a central electricity authority, would you?
You will still need the network, the electricity grid, because It's like the motorway. You might have houses all around Cyprus, but you need a motorway, you need the roads to be able to to have the main flow. So I strongly believe that you will have an electricity grid in the future. However, because your production now is distributed, you can maximize the benefits of having distributed generation by consuming and producing in the same vicinity. In order to be able to do that, you have to have your storage and you have to match your electricity with your demand. But of course, if you have excess electricity in one building, there's nothing stopping you from potentially selling your electricity to the next building, if you see what I mean. But right now we are focusing on making that building or the nanogrid or the microgrid into a smart system that can have a more effective operation, that can utilize the renewable energy sources, the battery storage, to have the energy management system, and to have the possibility to disconnect from the grid or to still be connected to the grid.
Battery efficiency has been one of the things, I think, up till now that's held back a lot of this sort of technology, but things have improved, am I right in thinking, in
Yes.
the last couple of years, so that now the batteries can store much more electricity, but we still have the problem, do we not, of, let's say, the surges of when electricity is being made, and then the surges when it's not, but the demand is great. That balance, if I remember the last time I spoke about this, was something that was potentially inefficient and possibly damaging to the whole grid system.
Yeah, battery prices are a limiting factor and they have been going down over the years. Battery prices are still not competitive in a lot of applications. You can see some of the applications for ancillary services that can potentially be beneficial. You see in the UK and Germany some applications for ancillary services. So we are seeing a very fast decline in the prices. So that's one point. Couple this with the low electricity prices from photovoltaics, and slowly you will see a change in the way things are operating. And this is why the battery storage is something that will enable the operation of nanogrids, of microgrids. You will see changes in the way that you interact, also the consumers or the prosumers interact with the rest of the parts of the system. So you will see a lot of changes in the future, and at the center you will see the so-called prosumer, so the people who are consumers and are also producers at the same time. So perhaps you will have your PV system, you will have your load, you will be consuming loads, so you will be able to be an active participant in this whole endeavor.
A lot of the buildings that this might be fitted to are not new buildings necessarily. How difficult is it to retrofit when you're talking about older architecture that didn't have these sort of possibilities in mind? Is it more expensive? Is it still efficient?
To be honest with you, the constituent parts of a nanogrid are the production, photovoltaics, let's say, the battery, so you can install the battery, and then you have the controller, so you have to be able to monitor your load, and you want to have also a software that can manage all that. So I guess it's much more difficult to do it with an old building, but there's nothing stopping you from having this concept in a retrofitted way.
And of course I assume that more newly constructed buildings, their energy efficiency is built in these days, isn't it, according to EU legislation?
Absolutely.
So their demand for power is presumably less,
exactly.
And that will mean that in the future there'll be an excess of power being generated.
Yeah, or the way that things are moving, you will only produce as much as you need. So if your energy demand is lower, there's no need to produce more energy. So I would say that first of all, minimize your demand, your energy demand, and then produce as much electricity as you need to cover your demand.
But doesn't that sort of nullify the whole idea of having grid systems dotted all over the place where people who aren't actually producing, just consuming, can consume yours and presumably that gives you a little bit of a profit to maintain your equipment.
Yes, that's a very big question. A very big topic you've raised, because all these financial models are only evolving now, because it's a new concept. So nobody knows what the optimum way of moving forward is. But obviously, one way forward could be that if you're a producer and then you can sell electricity to the neighbor in a peer-to-peer scheme. Yes, these are all evolving. These are new concepts now, which haven't been around the last few years, because it's something really new.
It could revolutionise our use and our view of how we manage our power, and of course it will reduce emissions, one takes it.
That's the end goal, and global warming, and this is the end goal. It's so important to alleviate all that.
How long's the project going to last? When will you get the results and be able to say, this is what everybody needs to do?
Oh yeah, you're stressing me now. We have to install the systems in the first 12 months, and the project is going to run for 3 years. So after the 12 months, we have to start collecting data and try to influence the policy and look at all the different barriers and how to move forward. And of course, to engage with the public, because they're an important part of the equation.
And that is Professor Yorgos Georgiou, who is the project coordinator of the FOSS Research Centre for Sustainable Energy at the University of Cyprus, and their new project supporting innovative and cost-effective energy rehabilitation in public buildings.